5 centuries ago, humanity's view of the universe was profoundly different from today's. The belief that the Earth was the center of the cosmos, around which the sun, the moon, and the stars moved, reflected an anthropocentric perception of existence. This geocentric model, supported by philosophers like Ptolemy, not only placed humans at the center of the universe but also considered them the apex of divine creation, reinforcing a reassuring vision of human existence within an immutable cosmic order. The advent of the scientific revolution, with key figures such as Nicolaus Copernicus, Galileo Galilei, and Johannes Kepler, radically transformed this understanding. Copernicus, in the 16th century, proposed heliocentrism, theorizing that it was the Sun, not the Earth, at the center of our solar system. This was a paradigm shift that began to shake the foundations of the geocentric view, though it met considerable resistance from the religious and scientific authorities of the time. Galileo, armed with his telescope, provided observational evidence for heliocentrism, observing among other things the phases of Venus and the moons of Jupiter, elements that could not be explained by the geocentric model. Johannes Kepler, through his work on the laws of planetary motion, further consolidated the heliocentric view, demonstrating how planets orbit the Sun in elliptical orbits, not circular ones, as previously thought. Today, our understanding of the universe has vastly advanced. We know that our solar system is just one of billions in the Milky Way, which in turn is one galaxy among the billions that make up the universe. The latter is also expanding following the Big Bang, a cosmic event that occurred about 13.8 billion years ago and gave rise to everything we know. The multiverse theory represents one of the most fascinating and speculative frontiers of contemporary physics. This theory posits the existence of an infinite number of parallel universes to our own, each with its own physical laws, constants, and potentially different forms of life. The theory has its roots in quantum mechanics and the principle of superposition, according to which particles can exist in multiple states simultaneously until observed. The many worlds theory, formulated by Hugh Everett in the 1950s, extends this concept to a cosmic level, suggesting that every decision, every quantum event that involves indeterminacy, may generate a new universe. In this way, reality branches into an infinite number of parallel scenarios, each representing a different possible outcome. Despite the speculative nature of the multiverse theory, some clues might suggest its existence. One of these is the fine-tuning problem, the observation that the fundamental constants of the universe seem to be incredibly precisely tuned to allow for the existence of life. Some scientists argue that, in a multiverse, with an infinite number of universes each with different physical parameters, it would not be surprising to find at least one where the conditions are right for life as we know it. Another area of research that might offer clues about the nature of the multiverse is the study of black holes and high-energy particle physics. Some theories suggest that black holes could be portals to other universes or that quantum effects near their event horizon could reveal clues about the multiversal structure of existence. Furthermore, recent advances in string theory and theoretical physics propose the idea that our universe might be just one among a vast amount of universes floating in a multi-dimensional landscape. According to string theory, elementary particles are actually strings that can exist in more than 3 spatial dimensions. The different modes of vibration of these strings determine the properties of particles, such as mass and charge. In this context, it is conceivable that different configurations of the extra dimensions could give rise to universes with distinct physical laws. These investigations into the multiverse are not just theoretical exercises but represent attempts to answer some of the deepest questions about our existence. If infinite universes exist, this raises philosophical questions about the uniqueness and meaning of human life, the nature of fate, and whether, in some parallel universe, alternative versions of ourselves might have made different decisions, living completely different lives. However, the multiverse theory also poses significant challenges in terms of scientific verifiability. Since parallel universes would, by definition, be inaccessible to each other, finding direct evidence of their existence remains a daunting task. Some critics argue that without the ability to empirically test the theory, it risks remaining in the realm of philosophical speculation rather than rigorous science. Despite these challenges, the allure of the multiverse concept continues to inspire both the scientific community and the public. The possibility of conceptually exploring universes where the laws of physics, history, or even our personal choices differ from those of our world opens unprecedented imaginative horizons. It forces us to reflect on our place in the universe and the infinite potentials reality might offer. Perhaps, as ongoing research in quantum, physics and high energies suggests, one day we may find more concrete clues about the existence of the multiverse, or perhaps we will develop technologies capable of perceiving or interacting with parallel realities. Until then, the multiverse theory remains one of the most intriguing frontiers of modern science, a symbol of human insatiable curiosity and our unceasing quest to understand the mysteries of the universe. The multiverse theory, therefore, not only serves as a topic of fervent scientific debate but also invites us to contemplate the vastness and complexity of the reality that surrounds us, reminding us that, despite how much we have learned, much still remains to be discovered. It reminds us that, in a universe or multiverse of infinite possibilities, the adventure of discovery is far from over. And so, as we continue to explore the outer limits of knowledge, we remain open to the surprises that the universe may have in store for us. Whether the idea of parallel universes fascinates or frightens you, it's undeniable that it presents a stimulating challenge to the imagination, an invitation to dream and reflect on what might exist beyond the known boundaries of our world. As we await future discoveries, speculation about the multiverse remains an inexhaustible source of inspiration for scientists, philosophers, and dreamers, encouraging us all to look up at the sky with wonder, curiosity, and a renewed sense of possibility. The multiverse theory, with its profound implications and fascinating mysteries, accompanies us on this journey, reminding us that exploring the unknown is one of humanity's noblest adventures. What do you think about this theory? Does the idea of an infinite multiverse inspire wonder or raise questions for you? What implications do you believe it has for our understanding of the universe and our place in it? Leave a comment with your thoughts and don't forget to subscribe to not miss future explorations of these and other fascinating mysteries of the universe. Thank you for following this journey through the infinite possibilities that science and imagination offer us.